deals with systems of equations and systems of inequalities. Okay, so we start with system of equations first. So 5.1, systems of equations in two variables. So first of all, what is a system? It's basically two equations put together, meaning both have to happen at the same time. So we're talking right now about linear systems of linear equations. Later on, we'll talk about non-linear equations. But right now, we're going to talk about linear equations. And I'm just going to pick an example, and then I'll open the floor for you to pick after I finish my explanation. So here's an example. Let's say x plus y equals 4. And let's say y equals 3x. A very simple system. Well, if there are linear equations, this is a linear equation. The graph of a linear equation is this, with a positive slope, or this, with a negative slope. Can it be horizontal? Yes, it can. But for now, let's just focus on these two possibilities. Okay, the same thing for the second one. So what are the possibilities? What are the options here? Option number 1, option number 2, and option number 3. When I graph these two, they may look like this, which means that there is only one solution. The system is called consistent. Consistent system. The equations are independent of each other. Independent equations. And there is one solution. If the system has solutions, one or more, the system is considered or called consistent. Just imagine two roads. I don't know, Ritchie Highway and College Parkway, right? There is only one solution. They only cross once. That's exactly the situation. Okay, what is the second possibility? Well, the second possibility is when lines are parallel. But if they are parallel, the system is inconsistent because there are no solutions. No solutions. Inconsistent system. We have no name for the equations. Parallel lines. And what is the third option? Here's the third option. This is one equation, and this is the other one. Which means system is consistent because each and every point belongs to both equations. So infinitely many solutions. You can say that there's the same equation twice. Yes, I agree. Consistent system because it has solutions, one or more. And the equations are called dependent. It's the same. Dependent. So when we solve, and we're going to get to solve in a minute, systems of two linear equations in two variables, two linear equations and two variables, x and y. These are the only possibilities. One solution, consistent system, independent equations. No solutions, parallel lines, inconsistent system. Or infinitely many solutions, of course consistent system because it has solutions, and the lines are called dependent. Okay, so let's start with this. We're going to look at two different methods of solving. The method of substitution and the method of elimination. One, two. Okay, so I'm going to copy the same system one more time. This is a typical situation for substitution. What am I saying here? Y is the same thing with 3x. Why don't I replace this y by 3x in the first equation? Because y is the same with 3x. So then the new equation, number one, is x plus 3x equals 4, or 4x equals 4, or x equals 1. So this is the situation. It's a one solution, but I have to find the ordered pair. Just finding x is not good enough. But there is no problem. I will go back and replace x by 1, and I get y equals 3. So what is the solution? 1, 3. Is it true? I don't know. I'm going to go back and check. Is it true? I have no idea. 1 and 3. 1 and 3. Is 1 plus 3 4? Yes. Is 3 times 1 3? Yes. So the answer is yes. The equations are independent, the system is consistent, and the system has exactly one solution. Two straight lines cannot meet in 2 points. They meet in 1 or all. They cannot meet in 2. It's not possible. 1 or all or none. So 1 or all. Okay. Any questions on substitution? Okay, I want to choose another problem. So let's take a look at 4x plus 3y equals 0 and 2x minus y equals 0. For now, let's stick with substitution, and then I'll present the elimination method. Okay. So when I substitute, I have to make sure that I'm able to present either equation in this kind of format. 1, whatever, x or y, 1y equals something. Well, I cannot solve this equation for x because then I'll have a division. I mean, I can, but I don't want to. I don't want to replace a fraction. I want to make it as simple as possible. The same thing with y, because if I move 4x and I solve for y, I have another fraction. The same thing with x here. But look what happens if I simply move y, which has 1 or negative 1 in front. So then I have y equals 2x. Very simple. I will replace y in the first equation by 2x. And the new equation 1 becomes 4x plus 3 times 2x is 6x equals 0. I have 10x equals 0. 10 times what is 0? Of course, x is 0. Is this good enough? No, because I have to determine y. 2 times 0 is also 0. So it turns out that this system is also consistent. The equations are independent, And the only solution is 0, 0. Is it true? I don't know. Very simple. 0, 0, 0, 0. 0 plus 0 is 0. 0 minus 0 is 0. Done, done, yes. The system is consistent, independent equations, one solution. And when I check, that solution has to verify both equations. If it does not verify both equations, it's not this point of intersection. It's probably a point here, or a point here, or a point here. Who cares? We only want to find the point of intersection. Therefore, the ordered pair has to verify both equations at the same time. If it verifies one and not the other, it's not the solution. Any questions so far? Anyone? Okay, so let's look at one more. Is anyone with me? Yes, no?
Yes.
Okay, thank you. So here's another one, 2x plus 5y equals 1, and negative x plus 6y equals 8. I think you're going to enjoy this part of the course. Okay, which of these will you solve for in order to use substitution? For x from here, for y from here, for x from here, or for y from here? Because I still want to use substitution.
Would we solve for x in the second one?
Yes, of course. Because it's the only one with coefficient 1. 2, 5, and 6 will create fractions. This one will not. So I will move 6y to the other side. And I have to multiply both sides by negative 1. So x equals 6y minus 8. So now I will go to the first equation, because I haven't used it yet, right? And replace x by 6y minus 8. Why? Because x and 6y minus 8 are the same. So 2 quantity 6y minus 8 plus 5y equals 1. This is a manipulation in a way so that I can create an equation with only one variable, because that's the only one I can solve. I don't know how to solve an equation with two variables, right? But if I somehow manipulate, which I just did, solve for x and plug in 6y minus 8 back in the first equation, now I have an equation with only one variable. And now this I can solve. Once I solve this, then I go back and find x. So 12y minus 16 plus 5y equals 1. This with this is 17y. Of course, 16 does not belong on this side, goes to the other. Nice number, very nice. Y equals 1. Is this good? Yes, but not good enough. I have to find the point. Or that there are no solutions, or that there are infinitely many solutions. So just x or just y is not good enough, but no problem. 6 times 1 is 6. 6 minus 8 is negative 2. So x is negative 2. Always remember, negative 2, or I meant to say x is always first. Y is always second, no matter in which order you determine them. X is always first. Y is always second. X coordinate, Y coordinate. Is this true? I don't know. I have no idea. But it takes a blink to check. Negative 4 plus 5, yes. 2, because it's minus minus. 2 plus 6 is 8, yes. And now I say yes. And again, one solution, consistent system, independent equations. Any questions on substitution? Is it easy enough?
I think it's pretty easy.
Good, awesome. So now let's look at elimination. I did not forget. We're going to look at examples like this, but I just would like to look at the elimination method. So the second method, elimination, I like to call it elimination. Your book calls it the addition method. That's fine. Perfect. We are going to eliminate by adding. So basically, these two are the best together to name this method. I like it elimination because I'm eliminating one of the variables, but so I'm doing the same thing here. I'm eliminating one variable, creating an equation in one, only one. I eliminated x. I determined y. Once I have y, I go back and find x. But this is a different scenario, but it's the same idea. Bottom line, the same idea. I need to get rid of one of the variables. Good. So let's see how the eliminating by addition method works. Okay, so I'm choosing an example. And after we finish this, I'll let you choose any example you want. So let's say 2x minus 7y equals 2. And 3x plus y equals negative 20. I know you will say, solve for y, plug it in, you're done. True. Yes, I agree. But now I would like to use the eliminating by adding method. How does this work? First I look at the coefficients of x. Before I mention that, I want to say something. If I have, let's say, 3x plus 2y equals 10, and let's suppose I have 2x minus 10y equals 20. Just as an example, am I allowed to add row line by line? Yes, I am. Because if these equations are correct, then 5x minus 8y equals 30 is also an equation that is correct. How come? Well, these two are equal. If I take this side and add it here, and I take this side and add it here, I'm going to create a new equation that is also correct. Because these two pieces are equal to each other. Just imagine 1 pound of salt and 1 pound of sugar. They are equal in weight. If I add 1 pound here and 1 pound here, I'm not going to change this equation because I am allowed to add 1 to each side and the equation stays the same. So this is basically the idea that we're going to use here. So I'm allowed to add this piece because it equals this. I'm adding this piece here and I'm adding this piece here because they are equal. So the new equation is still a valid equation like the other two. So that's the bottom line here. But there is a technique and there is something that we have to worry about. Not just adding. What did I do? Nothing. I just created another equation that is unsolvable. But what we're going to do here is going to be solvable. Because the point I was making here is to understand why we are adding eventually. Because these two are a balance, and I am allowed to add this part here and this part here to create a new equation. Okay, that's just the bottom line. Okay, so coming back to our analysis, to see how this method works. Coefficient 2, coefficient 3. In order to eliminate x, I will have to multiply the numerator, the first equation by 3 to get 6x, and this equation by negative 2 to get negative 6x. So then when I add them, this term goes away. So that's what I have to do if I want to eliminate x. Let's move on. We have to make a decision in a moment. If I want to eliminate y, I only need to multiply one of the two equations. Not this one, but this one. By what? And the answer is by 7. Why by 7? Because when I draw a line like I did here, the negative 7 plus 7 will be 0. So I'm eliminating y. So therefore, that is a better option. I'm going to multiply the second equation by 7. Not just this term. No, no, no. Everything. Because if I multiply everything by 7, I don't change the equation. So I copy the first one. 7 times 3x, 7 times y, 7 times negative 20. These are still correct and consistent equations. I created another equation that is identical with the first one, because if I divide both sides by 7, I get this back. So, what was the purpose? Here's the purpose. 21 plus 2, negative 140 plus 2. I eliminated y. How did this happen? Because I realized that this coefficient is negative 7, and only if I somehow get a 7y, the two terms will go away. Because as I'm allowed to add this piece here, and I'm allowed to add this piece here because they are equal to each other. So now all I have to do is divide both sides by 23. And that will be the answer. Okay, so when I divide, I get x equals negative 6. Is that correct? Is that correct? What am I getting? Can anyone divide for me? 138?
It's negative 6.
Okay. Okay, perfect. Good. Is this good? Yes, but not good enough. I have to go back to any of the equations. It doesn't matter where. Replace x by negative 6. 2 times negative 6, negative 12. Minus 7y equals 2. Negative 7y, we move 12 to the other side, it becomes positive. Divide both sides by negative 7, y equals negative 2. My claim is negative 6, negative 2. X is first, y is second. Is it true? I have no clue. But it's very easy to check. Negative 6, negative 2, negative 6, negative 2. Negative 12 plus 14. Negative 12 plus 14, that's correct. Negative 18 minus 2, negative 20, that's correct. And now I can say with certainty, yes.